Welcome to the fifth part of decimals. In earlier parts, we have seen what decimal is, what are decimal places, and addition, subtraction, and few operations on decimals. Let's quickly revise what are decimals. Decimals are fraction numbers with denominator as 10 or a multiple of 10. For example, 1.2. It can be written as 12 by 10. 1.25, it can be written as 125 divided by 100. So the denominator is a multiple of 10 or 10 itself. Then comes what are decimal places. Decimal places are the number of digits after the decimal point. For instance, 1.25, once again if I take, 2 and 5 are after the decimal point. So there are two decimal places in 1.25. Another example is 1.3. After the point, there is only one digit. So it means that there is only one decimal place in 1.3. Then comes the concept of like and unlike decimals. As we have dealt with earlier also, like decimals are, for example, 1.3 and 2.7, where there is only one digit after the decimal point in both the cases. Here I have 5 comparisons to be made. First of all, what we see is that the number of digits after the decimal, are they equal in 42.07 and 42.7? No. Here there are two decimal places, here there is only one. So as I told you, we put a 0 after 7. It will not change the number because 42.70 is same as 42.7. As many number of zeros as I can put here, it will not change the number. So now I start comparing these two numbers, 42.07, 42.7. First I compare the whole number. It's 42 here as well, here as well. Now I compare the first digit after the decimal. Here it is 0, here it is 7. Obviously 7 is greater. So we make this sign here because this number is greater than 42.07. Next, 5.00 and 5. Once again, when I see the number of decimal places, here is 0 and here is 2. So I make it, first of all I have to make them like decimals. Before comparing, I have to make them like decimals. I put 2 zeros after 5. Now if you can see, the whole number is also same. Then there are 2 zeros on the decimal places. So once again, these two numbers will be equal. They are equal. Here if I come, 0.34 and 0.56. 0.34 can be said as 0.34 or 0.56. There is no need to say 0.34. Now when I see here, there are two decimal places in 0.34 as well as 0.56. So 0.34 and 0.56 are like decimals. So we start the comparison directly. Here when I see the whole number 0 and 0 both are equal. Then I see the first digit after the decimal point. It's 3 here and 5 here. Obviously 5 is greater. So I put a greater than sign for this number 0.56. Next I come to 0.89 and 1. As I can see, once again they are unlike decimals because this is having two decimal places. Here it's only the whole number 1 given. So first let's make it like decimals by putting 2 zeros after 1. 2 zeros because here there are two decimal places. Now if I compare this 0 and 1, obviously 1 is greater. That means here in the comparison of whole number itself, we get that this number, that is 1 is greater than 0.89. 0.89 is smaller than 1. Then here 13.7 and 23.7. Here if you see that the whole number 13 and whole number 23, they are comparable because 23 is obviously greater than 13. Whether we make them like, whether we do not make them like decimals depends on the whole number also. Here in this case, Had it been only 1, had it been 0.89, there was no need to make them like decimals, because already the whole number part here is greater than 0.89. The whole number part is 0, here it is 1. Here 23.7 is greater than 13.7. So these are the comparisons of different decimal numbers. We'll see a few more. So here, now I have another set of numbers which I have to compare. 43.4 and 43.004. Here the whole numbers are same, 43 and 43. Then we compare the first digit. Here it is 4, here it is 0. Obviously 4 is greater. So 43.4 is greater than 43.004. 0.7 and 0.07. Once again the whole numbers are same, that is 0. And it is 0.707. 7 is greater. We compare the very first digit after the decimal point. And here 7 is greater. So that means 0.7 is greater than 0.07. This case is a different case. See here 5.223. 5.224. What I see is the whole number also is same, 5. The first digit after the decimal is 2, here also 2. Once again it is 2 and here also it is 2. So we compare this last digit, 3 and this 4. 4 is greater. So unless and until I am getting a digit which is unequal, here I am stating all 3 digits as equal. So here when I compare 3 and 4, I find that 4 is greater. So this is the number. Here 0.167 and 1.67. At one glance it might seem that 167. No, it is not 167, it is 0.167. Any number which has a whole number as 0 is obviously less than 1. And here the whole number is 1. So directly, without making them like, without making them thinking twice, we can just compare them with the whole number. Here it is 0, here it is 1. So this number is greater. As I said, any whole number which is 0 in any of the decimal numbers which is 0, it is obviously less than 1. 0.99 is also less than 1. So here it is greater than 1. 1.67 is greater than 1. 4.02 and 4.20. The whole numbers are same. The first digit is 0. The first digit is 2. So here also we can stop. We do not need to compare the other digits, because as it is, the moment we are getting unequal digits, we have to stop. 0.100, 0.01. Whole numbers are 0 in both the cases. The first digit is 1, the first digit is 0. So this number is greater. Even if I put 10 zeros here, it will not be accountable. See, if I put another 3 zeros here, it won't make the number greater than this number, because it depends on this number, this digit. This is greater than 0, here it is 1, here it is 0. So the very first digit which is unequal, that has to be taken into account. So that's all for today. Stay tuned for more and more videos on decimals. Hope you're liking all our videos. So send in your queries and suggestions in the comment box. Share the videos with your friends and watch out for the latest videos. Press the bell icon. Subscribe to Idea Infinity.